So last weekend, I was at dinner with, I don't know, maybe 5 friends, and the server drops off the bill, and it was a total nightmare receipt.
Oh, the classic check splitting problem.
Yeah, exactly. I mean, it was split appetizers, a solo salad, someone shared wine. I completely froze.
You can't just do that in your head.
No, I literally had to grab a physical napkin and map out my logic just to split the check.
You needed a scratch pad.
I really did. And it's funny to think about that human need to write things down to process them, especially when you compare to what we're looking at today. Because we're talking about an AI doing exactly that to solve a major open mathematical problem.
That napkin scratch pad is actually the perfect analogy for today's focus. We're looking at a real breakthrough in how we collaborate with AI. Not just treating it as a calculator, but as a genuine reasoning engine.
Right. And for those of you tuning in, this is our Intellectually Curious series. It's our dedicated space for positive, uplifting deep dives into the wonders of the universe, really for anyone who loves learning.
And today's mission is unpacking how an AI became a legitimate research partner.
Exactly. Finding that kind of seamless partnership is a unique challenge, which is actually what our sponsor Embersilk specializes in. This podcast is sponsored by Embersilk.
Right. If you need help with AI training or automation or integration or software development, they are the absolute experts.
So if you are uncovering where agents could make the most impact for your business or personal life, check out embersilk.com for AI needs.
Highly recommend them.
So let's get into it. That real-world impact is exactly what legendary Stanford computer scientist Don Knuth was chasing. He was working on a future volume of his famous book series, and he basically hits a wall.
A very complex mathematical wall.
Yeah, with directed Hamiltonian cycles. Which sounds intense. Basically, for a massive graph of m-cubed vertices, he needed a general rule to decompose the connecting arcs into 3 distinct continuous cycles.
And he had it working right on a small scale.
He did, yeah.
Yeah.
But the universal solution for any size was just completely elusive.
Which brought his friend Philip Stappers into the mix. Philip took this open challenge to Anthropic's Claude Opus 4.6 model. But he didn't just ask for an answer. That is the key here.
Right, he instituted a really strict coaching method.
He forced the AI to document its ongoing progress in a file called plan.md. And it had to do this after every single test run before taking any further action.
That constraint is the absolute secret sauce here. By mandating that plan.md file, Philip effectively forced the AI into a continuous reflection loop.
Instead of just hallucinating a guess right away.
Exactly. It had to establish a chain of thought, evaluating what worked and what didn't. It's literally the digital equivalent of my dinner receipt napkin.
It really is. And that reflection loop triggered this mind-bending methodical journey. Over 31 distinct explorations, the AI actively course-corrected. It started with a standard depth-first search.
Then quickly recognized the computational bottleneck and just totally abandoned it.
Right. Then it identified complex mathematical shapes it actually called serpentine patterns.
And when that hit a limit, it pivoted again. Using fiber decomposition, it wasn't just brute forcing the same path over and over. It was actively analyzing its own failures to try entirely new mathematical frameworks.
Which brings us to Exploration 31. Just 1 hour into the session, Claude had its aha moment.
1 single hour.
Yeah. It output a Python program that perfectly solved the decomposition problem for all odd numbers.
Knuth's reaction in his report was just fantastic. I love this. He literally wrote shock.
Shock. He was absolute delight.
He really was. He called it a dramatic advance in automatic deduction and creative problem solving. He even noted that Claude Shannon, the pioneer of information theory, would be proud of the advance.
And the momentum didn't stop there. Another researcher later took GPT 5.3 codex to conquer the even number cases.
The scale of that sequel is staggering. They successfully tested the AI solution on graphs with up to 8 billion vertices,
beautifully mapping out an unimaginably complex structure.
Seeing AI push the boundaries of human mathematics like this is deeply inspiring. We are looking at an incredibly optimistic future here, where AI is a tireless creative partner, helping humanity solve complex problems at a pace we've never seen before.
It totally shifts our entire perspective on what's possible.
It does. And, it leaves you with a really provocative thought for the future. If an AI can deduce the math of 8 billion vertex graphs in just a few hours today, what other totally unsolvable scientific mysteries might it help us unlock tomorrow?
Curing diseases, designing clean energy, the potential for human progress is just limitless.
It truly is. Well, if you enjoyed this podcast, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.